Okay, I know we just started 2026, but just for a moment, let's dial back the clock to Christmas Eve, 1968. I know, right? Wood paneling, shag carpets, I get it. I'm 7 years old, and I'm standing in front of a grainy black and white TV screen. And on that screen, 3 astronauts are wishing me Merry Christmas from, of all places, the moon. I was in absolute awe. This was the Apollo 8 mission, and it was the very first time that we had flown beyond Earth's orbit. And here's the thing. Their navigation computer had to get it just right. Too much thrust, and they'd fly right past the moon and be lost in space forever. Too little thrust, and the moon would grab them, pull them in, and they'd crash on its surface. It had to be perfect. I'm staring at this marvel of engineering thinking, wow, we can build machines and computers that can take us to the moon. And then I look down at myself, covered in angry red rashes and scabs. My body was overreacting to many of the same things that you and I come into contact with every day. Too much thrust. I had to wonder, does my body have a control computer like the Apollo 8 capsule? And if it does, could I reprogram this computer much like a NASA engineer would? Reprogram it to behave better? Turns out I wasn't the only one wondering about this. At around the same time, a scientist named Stuart Kauffman was asking a very similar question. Could the cells in our body have their own control circuitry? Not long after that, Eric Davidson at Caltech even coined the term genomic computer to describe our DNA. That idea turned a lot of heads. Engineers and physicists started migrating into biology, bringing with them their knowledge of control circuitry and advanced control systems. Because suddenly, biology looked like something that we could program. Then came an even bolder thought. If a single cell can behave like a tiny computer, what happens when I bring millions of them together and they start talking to one another? Could they form something bigger, something more sophisticated, a kind of thinking machine? When transplant biologist Charlie Orose proposed this idea, he was referring specifically to the cells in our immune system. This ragtag pack of cells that roam through my body, fighting infections, healing wounds, cleaning up the mess when things go wrong. And they don't just roam around randomly, aimlessly, ignoring one another. They follow a game plan. They follow a program. They coordinate their actions, and they learn from experience. Oh, and they also remember. So let's think about this for a second. If our immune system is like a computer, then those immune cells are like processors. They're constantly running programs. Fight infection, heal wounds, clean up damaged cells. Oy vey, can it just stay nice for one day? And most of the time, they execute those programs beautifully, flawlessly. The right program for the right problem. But sometimes, just like us, they misread the room. They run the wrong program, and that's when things go sideways. Autoimmune illnesses like rheumatoid arthritis or lupus, these happen when your immune system mistakes friend for foe and turns against your own body. 1 in 15 men in this room will go on to develop an autoimmune illness at some point in their lives. And for women, it's roughly twice that number. And then there are these mysterious, persistent conditions that we don't understand very well, like long COVID. Between 1 in 10 and up to 1 in 3 of us who were able to muscle through the initial COVID infection are still struggling to recover fully. And sadly, this is nothing new. After the first Gulf War in the 1990s, tens of thousands of veterans came home with lingering symptoms: fatigue, brain fog, pain. These symptoms lasted for decades. Different triggers? Sadly, the same story. An immune system that seems stuck in limbo. So, under the wrong conditions, could a computer as sophisticated as this one, as my immune computer, could it get overwhelmed? Could it freeze? Could it lose track of what program it should be running? Think of the infamous Microsoft blue screen of death, right? I can see there's a lot of trauma in this room about and of course, this always happens when you need your computer the most, right? Like, for example, when you're writing your TEDx script. So what do we do when our computer freezes? Well, I usually just reboot mine. But can I reboot my body? Can I reboot my immune system? Well, let's think about this for a minute. If my immune system really is a computer, then maybe I can pop open the control panel on the back and see what's going on inside. At the time, I was working with an incredible team, and boy, did we have the tools to do it. Flow cytometers, mass spectrometers, immunoassays, the most amazing gizmos. These instruments let us take a roll call of immune cells in a single drop of blood, and even listen in on their molecular conversations. So, of course, we focused first on the people who were already sick, the people who were struggling with these persistent symptoms, whose bodies just couldn't seem to reset. And we decided to start an immune conversation of our own. But how could we get the immune system's attention safely? Well, exercise is a good stressor. That might do it. So we asked them to exercise on a stationary bike to their maximum capacity. Then for 4 hours, while they recovered, we collected samples of blood and analyzed these samples. What we found was nothing short of surprising. Imagine your smoke detector, blaring and blaring when all you've done is burn a piece of toast. I know you've all been there, right? That's what we saw inside the body. Repair signals firing and firing long after the exercise had ended. Normally, inflammation fades as I start to recover. Here, in these patients, it did not. Was the immune system stuck in some sort of survival mode, some sort of last-ditch effort to stay upright, an emergency response, running on repeat? And if that's true, how do I hit reset? So again, if my immune system is a computer and it's frozen, how do I reboot it? Well, pulling the plug isn't exactly an option, at least not an attractive one, not to me. But maybe I can turn to another computer to help me understand this one. And that's exactly what we did. For more than a decade, working with an incredible network of research teams across government, academia, and clinical science, we gathered everything we knew about how immune cells behave and how they interact with one another. We mined tens of thousands of research paper, wrote reams and reams of code, and pushed this into the biggest computer we could find. And eventually, we were able to build a rudimentary digital twin of the immune system. Now, the first question we asked our digital twin was a simple one. Can you get sick the same way that these patients do? So, we infected our digital twins with the equivalent of a digital virus. I'm going to use air quotes here. We exposed it also to digital chemicals. And after a week of computing on the equivalent of thousands of laptops running in unison, nonstop, the answer, it would seem, was yes. Our digital twin could reproduce the same molecular signatures that we saw in these real patients, as well as in people just like you and me. This was a real turning point. For the very first time, we had a plausible explanation for these illnesses, an idea of which biological processes break down and why recovery stalls. Now, of course, the bigger question was, now that I think I understand how and why you get sick, can I help you get better? So we made our digital twins sick again. But this time, we gave them access to the largest pharmacy we could find, the digital equivalent of every single FDA-approved drug. And we let them test thousands of these drugs individually, one at a time, and in combination, running nonstop for over 10 days, this time on tens of thousands of processors. Here's what we learned. If these illnesses are a safety net, a kind of fail-safe program for the immune system, boy, oh boy, are they incredibly stubborn. Trying to break free of them is like trying to pull a life preserver from the hands of a drowning person. It's not easy. In fact, no single drug used alone worked. But when we used two drugs in the right sequence, with the right timing, we were able to rescue up to 70% of our digital patients. The first drug was an anti-inflammatory, not a big surprise, but the second drug was a hormone regulator. Apply the first drug, calm the body right down. Then follow with the second drug, and boom, the body resets. I mean, of course, this is all very theoretical, and it's just a computer model. I mean, come on, how good could it really be? Well, pretty good as it turns out. Remember those veterans I mentioned earlier from the first Gulf War, living with persistent symptoms for decades? Our partners were able to create an animal model that reproduced that condition. So we tested our drugs individually, one at a time, then together, but in the wrong order. Nothing happened. But when we followed the sequence that our digital twin predicted, the mouse recovered. This was a watershed moment for us, a really exciting validation of all this work. So exciting that it actually went on to human trials. But most importantly, for the first time, families who had been marginalized for decades had something really important. They had hope. So where does this go next? Well, today at the University of Saskatchewan's Vaccine and Infectious Disease Organization, VIDO, we're building even more lifelike digital twins of your immune system. We're linking thousands of proteins and cells through tens of thousands of interactions. We're using the latest in artificial intelligence to help us fill in the missing pieces, and we're pushing all of this onto groundbreaking new platforms like quantum computers. And hold on, we're just getting started. Imagine this. One day, when you go to your doctor, maybe you won't just get a prescription for a pill. I think you might get a molecular recipe, a personalized update to your immune operating system. And for me, this comes full circle, because when I was 7 years old, covered in angry red rashes, wondering if my body had a control computer, I never imagined that decades later, I'd be helping to build one. I never imagined that with you, I'd be exploring the edges.